Hi everyone, I'm here honestly if you don't know me. So, okay. How many of y'all play sports? You can raise your hand. Okay, how many of y'all play sports outside? Now keep your hand up if you actually wear sunscreen when you play your sport. Great. So, according to Stanford's Cancer Institute, over 50% of athletes do not wear sunscreen when they're out on the field, which shows that we need to protect our athletes from these harmful UV rays that are outside. How many of you feel like when you're outside you get drained easily from the sun? Okay. That's from the sun's UV electromagnetic waves, which are beaming down on you and raise your body temperature. And when your body feels that happening, it kind of feels like, oh, I need to make sure that I'm regulating my temperature. So it uses its own energy to regulate its temperature, and then that's why you feel kind of drained. So this is just a kind of sketch graph of what is happening when the sun hits your skin. So right here you see the UVB rays, and there's two. So it's UVB rays that hit right here, and that goes only to the surface of your skin, and that's the kind of automatic results of when the sun hits your skin, and that causes aging and wrinkling in your skin, but UVA is more of a serious problem, and it's like more of a serious problem, and it can cause up to like really serious problems such as skin cancer. Which leads us to Eric Olson, which was a study at Stanford, and he was 20 years old when he was running on the track team, and he was on this team for 5 or 6 years running shirtless every day for 2 to 3 hours, and he conducted research, and he found out that he had melanoma. We need to do something as a community to prevent this issue from happening with our own students. So this is my design statement, and I hope that this design statement can actually affect our community and be able to prevent something like this happening to somebody in our community. So this is my design statement. It says to help prevent the possibility of burning, sunburning, skin cancer, and other effects to the sun. An outdoor pavilion will be designed and built in a central area between the fields on campus. They use trust calculations, hydropower, and solar power to cool players off. So these are some of the materials and methods that I used when I did my design. I feel like the X-Acto knife and cutting board were the most useful in my working with my design, because I didn't know how I would be able to cut through the materials that I was going to use, that I'll show you in my board in the back. But in order to cut them, I had to use a cutting board and then place my design on top of that, along with wax paper, and then cut over with the material in the X-Acto knife. So these are the methods that I use in 3 stages, starting with the truss design. So I had to consider uncontrollable factors and controllable factors. Uncontrollable factors would be something like sun, wind, and snow, the weight of snow, the force of the wind, and the deterioration that the sun can be on your materials. And then controllable factors were how heavy the materials that I was going to use on the roof, and code regulations, which are things that the state or government introduces into making structure. And those are things that you have to follow in order for your structure to be legally okay to build. So some of you will be like, what's a truss? So these are 2 examples of trusses. The one on the left is something that you probably see more regularly than the one on the right. The left is under a roof. That's probably a barn from what it looks like. It can also be used for houses, churches, other examples like that. and then on the right, it's under a bridge. Sometimes it's over a bridge as well, or encasing like the sides of a bridge. So to go back to the two other sides of my methods, the next thing I had to do was a sun study, which is kind of using geometry, so you can use math in real life, I figured out. So the next thing I had to do for this part of the study was the angle of elevation, which was figuring out where the sun would be in order to figure out the maximum coverage of the sun. And I used the months of March to November because those are the months that everybody's out in those fields the most. And I figured if those are the hottest months, they need coverage from the sun because that's when it's the strongest. So in order to do that, I had to use the median of means that I found from my data, which I'll explain later. And then the next part of my methods was model building, starting from the bottom to the top, starting with the base and support beams, truss model, which I just talked about in the group. So in order to put this in perspective, I figured that I need to figure out what the real life materials would be for my design. So I decided on concrete foundation, cedar wood for the support beams, and dimensional asphalt or shingles for the roof. So these are my initial sketches for my first model, which I'll show you at my board in the back, but these are the first models. These are called elevations, which are just one point of view from your whole model. And then on the left, no, the right, but the right was a rough sketch of where I wanted to place my model. So these are the first steps in model building, which are starting from the right. You can see high and the edge of the base. I had to cut a hole that was very precise in order to fit the support beams that you see here. And then the trusses would be ending up placed on these support beams right here. So this was the first finished basic model. I wanted to be able to know what I was doing before I put like my actual studies and data into my finished model. So these are the elevations compared to the real life model. And these are just more pictures. And then drafting, I did this drafting after I created my first model in order to put it into perspective with a scaled architectural board, which you can see right there. So this is the sun study that I did for my actual model. As you can see, this is the senior lot, and this is where I want to place the pavilion because this is a central area between this field and these four fields in order for everybody to have an equal walking distance, or basically equal walking distance to the pavilion. So these are the sun study data that I collected, starting with March all the way down to November. I chose a central day, like April 6th, because most people are out on the 6th. It's not close to a holiday or anything like that. So I started at the time 2:40 because most people start at 3, but some people get out there early. So I started at 2:40 and then at 5:40 in order to cover the whole time people would be out. So these last squares are just the averages of the first and the third. And I averaged those for each month and put them on this table. And this right here is just a sketch of what I did for the median of these means. So I took all of these and found the middle number. And these are the angles that I found for my truss. The top one being 84, the side one being 31, and the other one being 65. Starting with the sun being down the short side first. So I started creating my model, and I started with the base, making sure that there was enough trimming on the edges in order to get my support beams in there. Then I worked towards the truss models, which were very complicated because I had to figure out where they would go in order to make sure that they didn't break down, because if a roof falls on somebody, that can be an issue. So here were the trusses that I did, and going on to the next slide, we can see the almost finished product. I haven't put the roof on yet, but it was very important that I made sure that all the trusses were almost identical if possible, because something as precise as getting these angles down correctly was very important to make sure that the truss wouldn't fail. So in conclusion, I think the truss design could probably be the most faulty aspect, because when you're creating the truss, it has to be tested. In order to be tested, you need the real life solution, and it takes a lot of time, money, and resources that weren't available necessarily. So then I think that the materials used, those would only be an issue if there was an error in production or bad reviews given on what materials were used. And I think that the theoretical approach could be very useful to this campus and can help people in the end. So what did I learn? I think one thing that I learned was project management, being able to do something in enough time, because these trusses ended up taking way longer than I thought they would be. I thought it would take me about a week and a half, and then it ended up taking me 2 weeks and a half. So I had to change around my schedule and make sure everything was finished by the date it needed to be finished now. And I think I'll be able to use these time management, project management skills in college. Being able to do that will help me figure out when I need to get things in, turn things in, make sure I'm going to the right place. And I would like to thank my family, my teachers, and my colleagues for supporting me during this process. Any questions? Any questions? No? Okay, cool.